Hi everyone, welcome back to TECHMargadarshi. In today's session, we're kicking off our brand new Java tutorial series, starting with the very basics of Java. If you've ever wondered what Java really is, why it's so popular, and how it actually works behind the scenes, this video is for you. We'll explore what Java is and why it's still one of the most powerful languages today, its key features, and how Java architecture works, the different editions of Java, and where Java is used in the real world, from web apps and Android to automation testing and cloud computing. By the end of this video, you'll have a solid foundation of Java, perfect for beginners who are just starting their programming journey. So let's get started and dive right into our first topic. What is Java? Java is a high level, object oriented programming language developed by Sun Microsystems in 1995, and today it's owned by Oracle. It was designed to be simple, secure, and platform independent. Java follows the famous principle write once, run anywhere, which means your code can run on any system that has a Java virtual machine or JVM. When you compile a Java program, it's converted into bytecode, and that bytecode is executed by the JVM, making Java portable across platforms. It's one of the most popular languages used in web development, mobile apps, enterprise systems, and automation testing. Known for its stability, robustness, and strong community support, Java continues to be a foundation for modern software development. Now, here is the next topic. Why should you learn Java? Well, there are plenty of reasons that make Java one of the most reliable and in demand programming languages today. Java is platform independent, which means it runs smoothly on any operating system, whether it's Windows, macOS, or Linux. It's object oriented, so it helps you write modular, reusable, and easy to maintain code. Java is also a versatile language used in web development, Android mobile apps, backend systems, and even automation testing. It comes with a rich set of APIs and libraries, giving developers powerful tools and frameworks to build almost anything. With millions of developers worldwide, Java has one of the largest and most active communities, so help and learning resources are always easy to find. And of course, Java offers strong career opportunities. It's widely used in development, testing, and automation roles. It's reliable and secure, built with strong memory management and runtime checks. And best of all, Java is an evergreen technology. It continues to evolve with regular updates from Oracle, keeping it relevant for years to come. Now, here is the next topic. What are the key features of Java? Let's look at some of the key features that make Java such a powerful and popular language. Java is simple, it's easy to learn and use, especially for anyone who already knows C or C. It's object oriented, meaning everything in Java is built around classes and objects, which helps in organizing and reusing code efficiently. Java is platform independent, following the principle write once, run anywhere, thanks to the Java Virtual Machine or JVM. It's also secure, as it doesn't allow direct memory access and includes several built in security mechanisms. Java is robust with strong memory management and excellent error handling capabilities. It's multi threaded, allowing multiple tasks to run simultaneously for better performance. The just in time compiler, or JIT, gives Java high performance, making programs execute faster. It's portable, meaning Java programs can run on any platform without modification. Java also supports distributed applications through technologies like RMI and EJB, and it's dynamic, capable of adapting to evolving environments by loading classes at runtime. All these features together make Java a reliable, efficient, and developer friendly programming language. Now let's proceed further. How Java works. Let's understand how Java actually works. Java follows the simple but powerful concept: compile once, run anywhere. First, as a developer, you write your program in a .java file. That's your source code. Next, the Java compiler, also known as Javak, compiles this source code into bytecode, which is stored in a .class file. This bytecode is special. It's platform independent, meaning it's not tied to any specific operating system. When you run the program, the Java Virtual Machine, or JVM, interprets or compiles this bytecode into machine code that your computer understands. This is what makes Java truly cross platform. As long as a system has a JVM, your program can run anywhere. Now let's look at the three main components that make this process possible: the JDK, or Java Development Kit, which provides all the tools you need to write and compile code; the JRE, or Java Runtime Environment, which provides everything required to run Java programs; and finally, the JVM, or Java Virtual Machine, which actually executes the bytecode on your system. So, in short, you write Java code once and it can run smoothly on any device or platform that supports the JVM. Now, here is the next topic: explain Java architecture. Let's understand the Java architecture, the foundation of how Java programs are compiled and executed. The flow starts like this: source code.java compiled by Javak, converted into bytecode.class, and finally executed by the Java Virtual Machine, or JVM. Now let's look at the main components of this architecture. First, the JDK, Java Development Kit. It includes all the essential tools like the compiler, debugger, and other utilities needed for developing Java programs. Next, the JRE, or Java Runtime Environment. It provides the necessary libraries, classes, and the JVM, everything required to run a Java application. And finally, the JVM, or Java Virtual Machine, the heart of Java architecture. It takes the bytecode and converts it into native machine code that your operating system can execute. Now, what exactly is bytecode? It's a platform independent intermediate code generated by the compiler. That means the same bytecode can run on any system that has a JVM installed. The JVM performs several critical tasks. It loads, verifies, and executes the bytecode, manages memory automatically through garbage collection, and ensures runtime security and performance optimization. In the end, this architecture makes Java truly unique. You can write once and run anywhere. That's the true meaning of platform independence. Now, here is the next topic: applications of Java. Now that we know how Java works, let's see where it's actually used in the real world. Desktop applications. Java is used to build standalone software like Eclipse and IntelliJ IDEA. Frameworks such as JavaFX and Swing help developers create rich, interactive, graphical interfaces. Mobile applications. Java has been the core language for Android development for years. Even Kotlin, the modern Android language, is built on top of Java. It's used extensively in Android Studio to build mobile apps. Web applications. Java powers the backend of many enterprise grade web systems. Frameworks like Spring, Hibernate, JSP, and servlets are the backbone of countless web applications. Enterprise applications. In industries such as banking, insurance, and e commerce, Java is the preferred choice because of its scalability, security, and ability to handle large user bases. Automation testing. Java is a favorite among QA engineers. It's the primary language for automation tools like Selenium, Appium, and TestNG, making it ideal for building robust testing frameworks. Cloud and big data. Java plays a huge role in modern technologies like AWS, Azure, and Hadoop, helping developers manage big data processing and cloud based applications efficiently. IoT and embedded systems through Java ME or Micro Edition. Java also runs on small IoT devices and embedded systems, proving its flexibility across platforms and environments. In short, Java is everywhere, from mobile apps and enterprise systems to cloud, IoT, and automation testing, making it one of the most powerful and versatile programming languages in the world. Here is next topic. Java Edition. Java comes in different editions, each designed for a specific type of application development. Let's take a quick look at the main ones. Java SE Standard Edition. This is the core Java platform. It provides the essential libraries like java.lang, java.util, and java.io. It's mainly used for desktop applications, basic Java programs, and standalone tools. Java EE Enterprise Edition, now known as Jakarta EE, it builds on top of Java SE and adds powerful APIs for enterprise level development like servlets, JSP, EJP, and web services. This edition is ideal for web applications, enterprise systems, and frameworks such as Spring and Hibernate. Java ME Micro Edition. This is a lightweight version of Java made for smaller devices. It's commonly used in IoT devices, embedded systems, and even older feature phones. JavaFX is a framework used for building modern, graphical, and media rich desktop applications. It supports advanced graphics, animations, and multimedia features for a more interactive user experience. In short, Java SE forms the foundation. Java EE powers large scale enterprise systems. Java ME extends Java to small devices, and Java FX brings visuals and interactivity to desktop apps. Together, these additions make Java a complete ecosystem, ready for every kind of development. And that brings us to the end of part 1 of our Java tutorial series. We've covered what Java is, how it works, and why it's so powerful. We will cover more advanced topics in upcoming sessions. So keep revising, keep practicing, and I'll see you in the next session. Thanks for watching and happy learning!